water supply which may come from a municipal water source and a dedicated water storage tank, or both. Hose connections and outlets. The location and number of hose connections and must be strategically placed throughout the building to provide adequate coverage for the firefighting efforts. The pipe sizing. The size of the pipe must be determined based on the requirements of the flow and pressure, as well as the length of the pipe runs. Normally, 4 and 6 inch is being used. So water pressure, we will determine how much is the pressure required, and FDC connections, as we discussed, it supplied for the additional water to the system if needed. Fire pump may be required to boost the water pressure flow rate for large buildings or building with low water pressure. So these are all the types of standpipe systems. Automatic dry standpipe systems, automatic wet standpipe systems, combined system, manual dry standpipe, manual wet standpipe systems, semi-automatic dry, and wet standpipe systems. So automatic dry standpipe systems. In this automatic dry standpipe systems, there will be purged air, means pressurized air or nitrogen will be pressured in this standpipe systems, and water will be on the either the blow to the connection to the floor of the tank or from the municipal connections. So in this type of these are empty and are filled with compressed air. Normally compressed air, nitrogen, either of these will be used. Water is supplied to the system when fire occurs, and this causes shall be maintained in the standpipe system across the section at should not exceed the pressure at 25 psig and 172 kPAG. What is kPAG? It is kilopascal. Kilopascal, G for gauge. Okay. By utilizing the nitrogen or compressed air with an air dryer. So automatic wet standpipe system, this is normally what we are using here. There will be a pressurized water, and whenever required, we will take the water from, we will connect the hose and we will take the water supply. So in this system, the pipes are already filled with water. Water supplied from a municipal water source. So when fire occurs, the system activated. Advantage is that these systems do not require firefighter to supply water and pressure to the system to make them work, because this will take the water from the water tanks. So they are commonly used in high-rise buildings where it would be impractical for the fire department pump enough water at a high enough pressure to deliver water to high flows. Combined system, it's a combination of both dry pipe system and wet pipe systems. So the dry pipe system, as discussed, will be purged with the nitrogen or compressed air, and we can connect the water to this supply. Manual dry pipe systems. Manual dry pipe systems will be used in areas where sprinklers are not required. Means there will not be, this pipe will be dry. There is no compressed air or nitrogen. Okay, it will be dry. After that, whenever required, the municipal water supply will be connected and we can use that. That is manual standpipe systems, dry standpipe systems. Connected to the valve allow. Manual wet standpipe system is water will be connected to the connection, and it is not connected to the tank. Instead, the connection will be given for the FDC connection. Okay, so this will be used for low hazard areas. When fire occurs, firefighters can connect their hose outlets and start the systems. Pipes that are connected to the source of water, dedicated water, cost effective. Same. Okay, semi-automatic dry standpipe systems. These are all similar to the automatic standpipe systems, where the function of the system is same, combined with both automatic and manual system, and is equipped with compressed air and a control valve that can be activated manually or automatically. Semi-automatic dry standpipe systems provides a reliable water source for firefighters. Semi-automatic dry systems are commonly used in high-rise buildings where firefighters may need to access the water supply from the different source. Wet standpipe systems. Again, the concept will the same what we are using, similar to automatic dry standpipe systems. Wet standpipe systems always have the water connected with the standpipe systems. The pipes are filled with water at all times and is equipped with outlet hose connections. Firefighters can attach their hose and deliver water to the fire. So wet standpipe system is easy to use and firefighter can use. Wet standpipe system commonly used in large buildings such as hospitals, hotels, and high-rise buildings where firefighters may need the access of the water from different points throughout the building. So that is based on application. Now we are classifying the standpipes based on its operation and configuration features. Okay. So based on this, there are three categories: class 1, class 2, and class 3 standpipe systems. Class 1 standpipe systems are installed for use by the fire department and are typically required for the buildings that have more than 3 stories above and below grade because of the time and difficulty involved in laying hose from the fire department directly to the remote hose. So here you can see what is this connection named? This is Siamese connection. Siamese connection in sense there will be two connections. So typically used class 1 standpipe is also known as Siamese connection, which are designed to allow multiple hoses to be connected to a single supply line. So the minimum residual pressure required for class 1 system is 100 psi from the hydraulically most remote 2.5-inch hose connection with a flow rate of 500 GPM. This is the requirement for the class 1 standpipe systems. Pardon? Yes, engineer. Based on the pressure requirements. Yes, if you see the class 2 standpipe systems, the pressure required is 65 psi. And here it is 100 psi. For class 2, it is 65. And there will be a 1.5-inch hose reel connections along with the minimum flow rate of 100 GPM. A pressure regulating device may be need to in order to limit the pressure of this hose connection to less than 100 psi residual pressure when flowing and 175 psi static pressure when not flowing. Why there is a pressure regulating device is required in the standpipe system? Yes, because the most remote sprinkler, what is the pressure for that? 100 psi. 100 psi. No, for any consideration, the most remote sprinkler will have 100 psi. And what is the riser pressure for this flow for this? Most remote riser will have 500 GPM. Most remote, the last riser must have 500 GPM and the last sprinkler must have the pressure of 100 psi. That is a design consideration we will consider before designing any of the structures. Okay, we will go through this at our last session as we discussed. While going through the design topics, we will go through this. Okay, the most yes, India.
Class one bar. 11 psi, nearly 1 bar.
100 psi. 100 psi.
100 psi.
Yes. The most remote here. I'll show you. This is the most remote sprinkler. If this is a system, this is risers, and the most remote sprinkler is F. So this last sprinkler must have a GPM of 500 GPM. The last riser flow, and last sprinkler must have minimum of 100 psi. Not 11, 100. No. Actually, I am telling 100 psi. Okay, 100 psi. Okay, almost, yes. Almost. So that is why we are keeping a pressure regulating valve for not exceeding the pressure to that psi. Okay. If it exceeds that, what happens is minimum pressure. No, actually maximum pressure. 100 psi residual pressure and the static pressure of 175. This is while flow condition and this is on no flow condition. Okay. What happens if this pressure exceeds? The bulb bursts and water comes out from the sprinklers.
Exceed.
Yeah, if it exceeds.
For the hose, this is not for the sprinklers.
No, this is not for, this is for the standpipe system, but standpipe system is connected to the branch lines, right? So if the pressure develops, yes, yes, zone control valve will be there. Yes, yes, yes.
There's two separate lines. No?
Yeah. Separate valve, yes. That is for high-rise buildings. In some areas, both the connections will be given to the standpipe systems. Even the sprinkler lines being taken from this standpipe systems, and a separate connection for the hose rail is being given. Yes, it will be distributed. In the zone control valve, there will be NRV, PRV, and everything will be there. Yes. So class 2 are installed for use by untrained professional and are often used in unsprinkled buildings. Okay, where the sprinkler is not required. Means this is used in low hazard area. Okay. They might also require to protect special hazard areas that such as exhibit halls and stages. And before going, please meet me. I will give you some important topics for you. Okay. One student I have attended exam and they passed this. Okay. So class 2 standpipe systems need to provide enough hose stations so that all portions of each floor level of the building are within 130 feet and 1.5 inch for hose connections. This 1.5 inch is for hose rail connections, not for the FDC connections. Okay, it's 2.5 inches. Okay. So class 3 standpipe systems are this combines the features of class 1 and 2 standpipe systems. The minimum size of the standpipe is 4 inch and the maximum is up to 6 inch. That is common consideration. Okay, branch lines of the standpipe systems may be sized hydraulically, but it cannot be smaller than 2.5 inches. 2.5 inch angle weld fire department use and 1.5 inch hose reel assemble for the industrial fire brigade use. Okay, this is common for 2.5 inch for FDC connection and 1.5 inch for hose reel or fire brigade connections. So water pressure and flow requirements. Automatic dry and semi-automatic dry standpipe systems. The minimum air pressure for this system is typically 40 psi and the minimum water pressure is typically 100 psi. This is for the, we have previously saw on the dry pipe systems, right? The compressed air will have a pressure of 40 psi minimum, and for wet standpipe systems, minimum water pressure will be 100 psi. The maximum water pressure of this system should not exceed 175 psi. So automatic wet standpipe systems, the minimum and maximum pressure for these systems should be between 100 and 175 psi. Manual wet standpipe systems between 65 and 100 psi. And for class 1 and 3, 100 psi is the minimum, and class 2, 65 is the minimum. They will ask you for this number. Okay, that is why I have included this data. Pressure requirements in high-rise buildings. In high-rise buildings, overcoming the pressure loss due to elevation, great demand on standpipes, pressure and hose reels on lower pipes. The system may be zoned and the pressure control valves will be installed. This is what we discussed previously. There will be a zone control valve and pressure control devices like PRV, NRV will be installed along with this zone control valves. Extremely tall buildings, upper and lower zones.
This zone control valve go to sprinkler branch.
Yes, yes. From standpipe systems, there will zone control will be there, NRV will be there, PRV will be there. After that, branch lines will be there. Where we are? Yes. So procedure for calculation. I am just giving you the basic for this, because calculation we will do it on the last session. So how we will calculate each sprinklers and what will be the consideration. We will look into the last session for the design topics. Actually, it will give you a vague idea of how to design from the scratch. So what is the rate of the pump? How much is the tank requirements? What is the how much hours rating it is required for? Those details we will discuss on the last session for the design topic. Actually, these topics are being considered for designing. Previously, it was for 15 mark. So that time it was for design, but now it will give you a basic idea of how to have a design. Okay. So class 1 and class 2, class 3 systems, the most remote riser will have 500 GP. And additional, each risers will have 250 GCM per riser. And the main consideration is it should not exceed 1250 GPM. If this is the 500 GPM, okay? And each riser, 250, 250, 250, 250, 250. Means 500, 750, 1000, 1250. So this, if you are adding these two risers to this system, it is not accepted. So we will have to have one additional riser, one additional system. Yes.
Also needed, or if we have 100 GPM pump, can we take 2 branches?
100 GPM? No.
1000 GPM?
1250 GPM is the minimum requirement for one riser. Yes.
For one riser, maximum 1250.
No, one riser, additional risers 250 GPM. So each risers will have 250 GPM. Means this is 500. This is 250. 250, 250, 250. Each one is 250. Means 500, 750, 1000, 1250. Only until this, we can use only one standpipe systems. Okay. If we are considering these two risers together, then we have to go for additional standpipe systems. We cannot use more than 1250 GPM. Yes.
It's not touching it.
Pardon?
Not matching. Because the 250 GPM, other 5 risers. Other 5 risers mean A up to E. Right?
1, 2, 3, 4, 5. 5 it is 1250. Additional riser. Total number not to exceed 1250. Means including this 500. Actually, 1250 plus 500 is 1750 here. It's exceeding. We cannot consider this system for one single standpipe system.
Correct the sketch, remove 2 risers.
Yes.
It will be confusing. Yeah. Okay. Total required discharge will be 1250. So apart from the flow, what we will consider? What is the pressure requirements? And each walls and fittings will have an equivalent length. So what we will consider, there will be a pressure drop, because if you are considering many fittings like elbows, T's, branches, there will be a pressure drop, right? So that pressure drop will also be taken into account. So if you consider the most remote riser to be 100 psi, then the given will be maybe 120 or 150 psi. Only then, after the frictional losses and elevation losses, we will get the most last remote sensor will have 100 psi. Correct? So that will be calculated using, this is the most last will be 100 psi for class 1 and class 3. So these losses will be calculated using Hazen-Williams constant. This C is known as Hazen-Williams constant. Okay. Hazen-Williams constant. Here it is not given. Hazen-Williams constant. Yes. Here you can see Hazen-Williams value. Yeah. So for 45-degree elbow, if you are considering 2 inch, then this is the equivalent length in inches. So we will calculate for this much length, total length, there will be a pressure drop. Correct? So elbow T butterfly valve, gate valve, we cannot measure the length. Instead, for each inches, what will be the equivalent length? From this equivalent length, there is a formula for finding pressure drop. Okay. We have to multiply with those factors. Here, if the value of C is 100, we have to multiply those factors with 0.713. If it is 130 and so on, you don't have to memorize these values. I'm just giving for the understanding. Okay, they will not ask you any of the problematic question regarding this. Okay. So indicate the typical C factors that shall be used for materials. Oh, this is for the pipelines. Unlined cast or ductile pipe, the value of C is 100. And black steel pipe, it is 100. Wet pipes, it is 120. So each pipes will have this, and each fittings will have a separate C value. So pipe schedule, standpipe systems, and piping minimum nominal pipe sizes in inches. What will be the flow, accumulated flow, and total distance of the pipe from the farthest outlet? So if it is if the requirement is 100 GPM, the outlet last pipe will be 2.5 inches. We are selecting the pipes.
50 to 100 feet, maximum distance.
Yes, maximum distance. Based on these conditions, for each flow in GPM and liter per minute, we are considering the total distance from the. If it is less than 50 feet, we will consider this. If it is between 50 to 100, this is the pipe size. If it is more than 100, this is the pipe size. We are selecting the pipes. Okay. You don't have to select any of the pipe in the exam. They will not ask you how much is the pipe requirements in those, but just for your understanding. So components of standpipe systems. There are many components of fire standpipe systems. The one is FDC connection, that is fire department connection. In fire department connection, there are two types of fire department connection: single inlet, double inlet, and wall mounted or freestanding. So fire department connections, location of fire department connections must be accessible from the street side of the building. You can see there will be in any of the open space, it is easy accessible. And the fire department connection identification, types and systems, inlet pressure requirements of the building itself. This is one of the wall mounted fire department connections. And other components are fittings, pipes and fittings. The components to install standpipe systems and the way they join must meet other adopted standards. Commonly used materials are ductile iron, cast iron, malleable iron, steel, copper. And the fittings to join together by a number of different gauges. Gauges determine the available of pressure, how much is the pressure inside that. Required at the top of each standpipe system, recommended on each side of the pressure regulating device, should not be subject to freezing temperature, should have a control valve capable of draining. So the other component is valves. Standpipe system may use different types of valves. There will be FDC connection, connection valve will be there. Prevent water flowing back to the FDC connection. There will be a NRV connection. Why we are using NRV connection to the FDC connection? Because yeah, in standpipe systems, they may be connected to the municipal water connections. So if the fire department connection connected to these standpipe systems may, of course, it may not be a drinking potable water. FDC water may not be drinking water. So if you are connecting to the standpipe systems, it will mix with the municipal water connection. So there will be a check valve to avoid this. Okay. And also to prevent water flow back to the FDC. If there is no check valve system, if the pressure development is more, there will be a backflow. Control valves permit the water to flow into when open, isolate parts of the system serving cells. Drain valves permit the water to purge from the system for testing and services. Hose valve system allow the fire to be connected. Pressure restriction and pressure regulating valves will be used. allow boost pressure to the high but manageable. Required. These are all common terms. Okay. Hose cabinets, hose and hose racks and nozzles. For sure, you can expect one definition of either of this. What is hose cabinets, hose racks? You can expect one definition from this. Okay, they will give you a definition and they will ask you what is the term for. Okay, hose cabinet is a metal enclosure mounted on the wall of building. Holes prevent water protection equipment, require labeling, and these are all general terms. Okay, hoses. There are two types of hoses: lined hoses and non-lined hoses. So here in Qatar, we are using only the lined hoses. Lined hoses against abrasion, corrosion, and chemical damages. Lined hoses are commonly used for fire department applications where the hoses may come in contact with chemical solvents and other hazard materials. Non-lined hoses, they are often used for mobility and is of crucial, but they may not provide same level of protection as lined hoses. Non-lined hoses are typically more lightweight and flexible, but it will not be protection. If there is any scratches, possible damage will be there. Here we are mostly using lined hoses. Okay. These are types of nozzles equipped with a shut-off type nozzles. So means only if we press, it will come. If you release that, it will automatically shut off. Hose reels and hose cabinets. You know about this. I'm not sitting much on this. ITM. Inspection, testing, and maintenance requirements. System must undergo acceptable testing. Fire building, insurance, and third-party inspectors should conduct the acceptance testings. Some tests occurs during the construction phase and others at the final handover. Throughout the life of the standpipe systems, periodic inspection, testing, maintenance is essential. So what are all the parameters they will test? Piping of class 2 and class 3 systems installed, including air piping, hydrostatically test for a period of at least 2 hours and not less than 200 psi. Or at least 50 psi in excess to the normal pressure when such pressure is greater than 150 psi. Okay. So either of this, we will consider maximum, whichever is maximum, we will go for that testing. And hose on, all standpipe system installed hydrostatically will with couplings in place at a pressure of not less than 200 psi before it is placed in service. So this pressure shall be maintained for at least 15 seconds, not more than 1 minute, during which the time hose shall not leak or shall any jacket thread break during the test. So similarly, like what we are testing the standpipe systems, we will test the hose reels as well. And air test. We will system subject to a minimum 200 psi water for 2 hours. Hydrostatic pressure will 24 hours of air test is required for dry standpipe system. 40 psi is the required pressure. We have discussed it on previous slides. Okay. Visual inspection. We will see all these parameters. Flushing. This parameter is very important. Okay. What is the flow rate required for the flushing? You will see this again on other topics as well. So flushing flow rate is 100 feet per second. Flushing is used to remove the dirt, debris, and muds before the line is being commissioned. Flow test. Flowing water from hydraulically most remote outlet determine the flow. Take place on the roof of the building, requires hose lines and nozzles. Pitot tube and riser gauge will, you know what is pitot tube? Pitot tube is used, it is not given here. Pitot tube is used for testing. Yes. And when the roof not accessible, water flows. Main drain test. So this is mainly for the we will close the all the zone control valves and we will test the standpipe alone. Okay. After that, we will open the drain valve. Remove the system water so it will not be hazard. Allow the inspector to determine there is enough water supply in the system as main drain valve is fully open. System gauge. Operation of components. Any component capable of moving requires testing under operating conditions. Almost every component requires unscrewing a cap and turning a valve to move water. Doing so provided a means to determine whether the system will operate when needed. Periodic inspection. Many fire protection systems have never actually operated. When a system is not tested and maintained, the operating condition is also. This is common term. Okay. Impairments. What is impairments? This is similar to a defect rectification. Okay. If there is any identified defects, we will do the rectification. That is otherwise technically termed as impairments. Some impairments are system related, some are not. Important of fire department companies to frequent tour their first duty area. Fencing, barricades, and bushing are physical ones. Unmaintained standpipe systems may be inoperable. Maintenance. Assure that there is a maintenance procedure, monthly maintenance, weekly maintenance, and annually maintenance will be there. Hose systems are inspected at least annually and after each use to assure that all of the equipments and hose are in places available for use and in serviceable conditions. When the systems or any portion of that found not to be serviceable, the employer shall remove it from the service. So hose existing systems, we will check whether it is cracking or not. Is there any damages or not? This is for visual inspections. HEM or existing systems, we will check the water if there is any leakage or not. The employer shall assure that defective hoses is replaced in accordance with the section. The employer shall designate a trained person to conduct an inspection required under this section. So this is not much important. So this is all about standpipe systems. They will you may expect to ask questions from types of the standpipe systems, definitions, and its classifications. What is class 1, class 2, class 3 type of systems, and from ITM, inspection, testing, and maintenance. What is the maintenance frequency for hose reels? What is the hydrostatic pressure? Such details you can expect the question from this section. Regarding maintenance, it is 2 or 3 pages. You can expect it is a long pages. Each section they give hose reels, hose, standpipe system. Yes. But in NFPA 24, I believe, you will have a consolidated inspection, testing, maintenance plan. So if inspection, testing, maintenance plan is asked, go directly to that section and refer. If it is not given, then you can come back to this section and NFPA 25, yes, inspection, testing. It will give you only a few portions, but NFPA 25, it will give you the detailed of all this. Okay. So I think we can move to the, if you have any doubt, you can ask, or we can move to the next NFPA. Pardon? Weightage of this question, NFPA 14 is maximum 2 to 3 questions. But marks will be around 5 to 6 marks, almost. (13) is very important. 13, you can expect many questions. Okay, so NFPA 15. Standard for water spray fixed system for fire protection. Same like all NFPA, you can expect some of the definitions like this. Okay, these terms are deflagration, detonation, what is flammable liquids. They will give you the definitions and ask you what term it is. What is combustible? There was one question about the combustible liquid. Even when you are practicing, you will, I think you might have seen this question, combustible liquid. They have asked on the real-time exam. Okay. And the ink pigment, insulated, uninsulated, delegible. These are all some of the important definition terms we may expect to ask. Okay, I'm not saying this. This is limited to only this. You can refer the definition sections. So, as we discussed in our sprinkler systems, the pipe requirements for pipes and tube requirements specification is also being given. The minimum pipe size shall be 1 inch for steel, galvanized, and 3/4 inch for copper pipe and stainless steel. The FDC connections will be 2.5 inch, and the connection using NH internal thread swivel fittings with 2.5 to 7.5 NH standard thread. This is the thread specification for the FDC connections. It is common everywhere. Okay. Sprinkler installation. Pilot sprinklers shall be permitted to be spaced more than 22 inch below the ceiling or deck where the maximum spacing between the pilot sprinkler is 10 feet or less. This sprinkler system is for water spray fixed systems. Okay. Pardon? In foam type of systems, you can. I think next topic will be foam type of systems. This is one of the similar type of. I'm sorry. This is one of the similar type of sprinkler systems which we are using water spray systems. So electrical clearance of you must keep away from this electrical balls. How much meters it is? This is given in the table. An altitude of 1000 meter, the electrical clearance shall be increased at the rate of 1% for. This is one of the very important table. For ordinary, what will be the density? This is called a density area chart. Okay. So based on this, a general range of water spray application shall be applicable to most ordinary. 0.5 GPM per feet square. Here you can see density 0.15 GPM per feet square for ordinary, having an area sprinkler of 4000